Alright, hello everyone, how's it going today? I'm doing another experiment with geometry nodes to see if I can get kind of simulation loops, or for each loops working, but instead of making them for each vertex on the object, I'm going to make it every object in a collection to see if that'll work. This will be an interesting test, but in theory, in my brain, it should work. So I'm going to have a cube, and this cube will be in a collection, but there will be multiple cubes, in quotes, in this collection. I'm not sure if I want these to be instances or not. I may save that for later. But let's start out with, no, let's just go with, let's do a 3x3 or 4x4. Let's do a 4x4 grid, because I want to see if I can get accurate collisions, where they can move towards a goal that I give them, but they will not collide into each other, and they won't both try to go into the same location. So 4x4 grid, like this. Each of them has simulations going with them, but I need to reference sim cubes. Going to reference this collection and see if this will be interesting if I can figure this out. So each one of these will want to move in a certain location, but there will be a check to see if there's something already in that direction. So I guess the idea is yeah, let's make it so that they all have to move towards the left. So let's store a target position. This will be interesting if I can get it to work correctly. Target position. Oh, there's a lot of people here already. Hello, everyone. Let's see. Yep, early stream today. I decided, you know what? I did some shopping today, and then I came back home, and I was like, let's go and do a stream. I feel like doing it today, so I will do it. So these cubes will want to move 1 meter each step, which, let's get the grid going. So, they'll want to move over to there, but I want to make it so that they cannot move where a cell is already occupied. I assume this will use the index of nearest. Not with this one. It's interesting because with the index of nearest... Actually, wait a second, can I? I need to think. The thing is, the index of nearest is a loop in and of itself, but the thing is it does everything at once. So if I want one cell to move, and one cell to move into where the other one was in the same step, like collisions still... We need proper, like, for each loops for collisions to be accurate. Because right now, if it all moves at once, then two objects that have the same destination where nothing was there at the previous frame, they'll both go... I'm doing hand motions, but you can't see it. Here, let me make a little diagram, or a little example. So if two cubes are right here, the index of nearest will say, okay, they're far enough apart so they can move. Or if they have the same destination, like right here, they can both move there. Which means that when they do move, they'll both end up in the same location, even though in the previous frame, it read as completely fine. So, for each loops, it would move this one over to here, and then this one would be like, okay, I cannot move, I need to stay here. So in order to do that, I'm just making every single different object each vertex a different object, with just the same simulation geometry node running on all of them. So it should do that, if I'm correct. Each one should happen in, you know, like an index line, like cube 1 should operate first, then 2, 3, 4, 5, 6. So that would mean that they can never end up in the same location, and they won't self-collide, if I can get it to work properly. So the thing is, I need to... Let's see, how do I... Yeah, we're, you know, another research and development stream yet again. We need to realize the instances. Wait a second, where are the vertices? 2 points. No, instances 2 points. Why am I not seeing... Oh, the collection contains current object. Okay then, well, we can't do that. Oh, that is actually unfortunate. So it looks like we'll have to use the index of nearest node, and I have to find another clever way to avoid that problem. Let's join all these vertices together. So now, yeah, I do need to use the index of nearest. But the problem is, like I said before, if we have two cubes and they both have the same destination in one frame, currently, it would be like, oh, that destination is clear, so both of these can move there, which means that they will collide into each other, because in the previous frame, it read it as clear. How would I make it? Like, that's why we need loops for completely accurate stuff. Raycast, no, raycast wouldn't work. Like, the index of nearest node would detect if one was already there. It would say, okay, I can't move there at the moment. But the problem is, if both want to move in the same location, they both read this as empty. So let me try some stuff out. So, okay. Let's use a set position node. So it wants to go, let's get a vector going. So it wants to go to the target position. So let's get the offset from that. And I do need to snap this. Let's see, I could snap this to 1 meter. I need to see if this works. Oh, wait, I need to normalize and then snap. But snap does not work with... Snap doesn't work with negative values, if I'm correct. Oh no, it does. Huh. I thought it didn't work with negatives. Turns out I was wrong. But here we have all of them moving. But here, they shouldn't... These front ones should move, and then the ones behind them should move, and so on. So I need to put in the little checker to see if it can move. So we use the index of nearest. So we take the offset it wants to do, and I need to add that to the current position. And basically need to do a geometry proximity, but with the index of nearest node, which shouldn't be too difficult to do. So let's do that and evaluate at index to get the position vector. Want to get the current position and then get the distance from... Wait, do we want the... Oh, wait a second. Or would that work? Okay, I need to try something. So the distance is greater than 0.1, it will move. Let's see. So that works. Maybe instead of having them go towards the target position, I'll have them move in random locations to see if they will collide into each other. Just to see. Uh-huh. So if it's greater than that distance, it will move. They should keep moving. Frame. Yes. Okay, so they should be... Okay. So I think it's trying to move into a location that shouldn't be... Yeah, all these are trying to collapse into one point, which is not what I want whatsoever. Okay. So one thing I kind of want to do... Okay, let me think about this. I want to put in some interpolation every, like, 10 frames or so. And I forget how to do that exactly. I need to... So I need to set, like, the target, the destination. Then interpolate between its current one and then its destination position. Sorry if this is getting complicated fast. It's geometry nodes. Let me just say that. So the current one in that. So I need to make it so that this calculation only happens once every so often. And then, let me think. Still thinking. Okay. So let's store a named attribute. This will be new position. And then switch. We'll switch between the current position and then the new suggested position. Like this. Only if this allows it, and then I need to put in the interpolator afterwards. So I need to switch. Wait a second, I'm getting fried already, which is not a good idea. Oh no, wait, this will work. Okay. So I'll switch between the change to the new stuff and then the interpolator. Okay. So I can change which mode this will do. So this will simply... Yeah, let's use a... that position. So I need so that this section will fire only once in a little while. Okay, so let's set up scene time frame. So I need to wrap this. And then say once every... Actually, wait. How do I make it mix reliably? And, okay, let's just do seconds. So every second, it's equal to 1. It'll flip and then recalculate the new position. And then let's use a fraction node to change the mix between the old and the new. If I'm correct. Mix vector. I'm getting a little confused. My apologies, everyone. Again, it's early. I wasn't planning on streaming today, but then I was like, you know what? Let's do it. It could be fun. Famous last words. Ah. Oh, and that happens because there is no current new position at the moment. Or wait a second, wait. It keeps saying, yes, wait, yes, wait, yes, wait. So here we can see the interpolation is working as intended. Even though it really sucks. This is bad. Not enough coffee. I'm actually not a coffee drinker. I haven't had it in a long time. I just never developed the habit. So I'm going to turn off the interpolation just because it's messing with my brain. And maybe I'll make it so that... Yeah, it'll just offset the position, but like... Let's see, set position, it'll just offset it, but I'll scale down the amount. And then, oh yeah, okay, yeah. Let's have a velocity, and then the velocity will update depending on... Yeah, okay, I can do that. That'll be a simpler way. So, velocity. Named attribute, velocity. There we have it. So this velocity will be updated using the switch node every 10 frames, and then that should work just fine. So scene time I need a wrap node, and then an equal to integer, so that if this is equal to 10, I could be wrong about this, but this should work. So this will start off at 0. Okay, yep, it works. So I just need that scaled down to 0.1. Okay, so now we should see... Yep, that does seem to be... Wow, oh, whoa. Okay, now the interpolation is working. It's kind of... Well, it's not interpolation, it's just moving it, but it is doing as I wanted. So let's use a switch node to say if distance is greater than... No, wait. Okay. Let's scale this so that if the distance is greater than, it'll keep the velocity move. Okay, there we go. So now we should be able to see that as working. And let me instance cubes on there. Mesh primitives cube. There we go. So now we should see... Okay, so these ones are colliding a ton. That is not what we want. So let me try to fix that. There we go. It seems as though it is doing nothing. Okay, so let's do the test where the target position is that away. So that should not be happening. Right now the collisions are doing absolutely nothing. That is not good. The offset if the position of the neighbor... Oh, something is... Okay, wait. Uh-huh. Well, something has occurred. And does that need to be greater than 1? No, it has to be greater than, like, 0.001 for it to work. So the question is... So we can see they're, for the most part, not colliding until that happens. Oh, wait, I know why it goes back and forth. That is because... Okay, yeah, I know. Because the distance between the target and the current... I need to say if the length is less than 0, then stop moving. Or only have it move if it's greater than 1. Greater than or equal to 1. Okay, so let's do that. Just need to plug that into there. I should start labeling all of this. So this is collider, self-collider, yeah, self-collider. This is target vector. There we go. So now we should see if I oh god. No, that needs to be greater than or equal to. There we go. So that does it. Whoa. Okay, so it works for the most part. I don't know what the heck is up with that one. What the heck is up with that one? Because that should not be moved. Like that one right there. Bad. That should not be moving. Let's have it so that that starts off on the first frame. I'm a bit surprised. Let's put the target location in a different place. Uh-oh. Let's set that back to 10. Something has gone amiss. I need to figure out what. T-position, yeah, no, that should be correct. Why is it not being convinced to move? Wait, is that wait a second. I think it's because the snap does not like working with negatives. So we can see that it does try going to its target position, even though the problems still do partly persist. Let's try this. Okay, so now it's moving as a coherent blob, which is interesting. But now I want to make them conflict a little bit, so that some of them have different target locations. Which that is why we put in the random value into here and set this to like 10 and 14. Let's see what happens. Okay, so we can see collisions are currently happening. Again, not the best in the world. Let's set this between 5 and 10, just so that when we replay the simulation, it doesn't take quite as long. So we can see that okay, so collisions aren't fully happening. But the ones that we do see are because these can travel diagonally. So I just need to make it so that they cannot... Wait a second. Okay, problem found. So this current setup, it takes the offset to the target position. And... wait a second, why is that not... Huh, okay, so that part isn't needed. I'm surprised by that, but not too disappointed. Subset the sim through repeating the collider. Well, that's the problem. In order for the collisions to be accurate, I would have to essentially loop it for every single cell in here to make sure that they can never collide, especially in this kind of voxel method. If we had for each loops, that would be no big issue, but we do not have those yet. We do not have those yet. Also, I need to figure out how to make it so that they cannot... Actually, wait a second. How do I make it so that it can only travel on one vector at a time? If I turn off the normalize... What happened? Oh my goodness. No, the normalize needs to be kept. I just need to multiply on the X, Y, or Z axes differently every single frame. So, can I do that? Let me try. So, multiply. Try multiplying this. Okay, so that happens. Let's multiply this by random value every single frame. And put the scene time so that this is randomized. Let's see. Yeah, it should be 1 or 0 if I'm correct. Oh, wait a second. No. Okay. Okay. Let me think about this. So instead of like that, I need to have this be a boolean. There's probably a much better way of doing this, but my brain power is saying, Ben, just do it in the simplest, the most straightforward way you know how, rather than the smart way. The way that needs to be a combine X, Y, Z. There we go. So, and then I need to make this a not. Or no, wait. Let's just try this for the time being and see what works. So that I can only move... There we go. Only move I want to axis at a time. So that's the goal. Kind of. But the problem currently is they keep colliding. Oh, wait. So now the only point where they collide... Maybe I should run 2 colliders instead. And then just say if this and that are currently working. Yeah, no, that should work. So this is the destination self-collider. There we go. So instead of that being like that, I need to feed in the offset version, which Here, let me move this out of the frame just so that... Let's see. F2 offset position. So, the difference between these two is one is the offset one, and this one is seeing the current one. If that makes sense. Okay, let's try this and see if it fixes. Nope, it does not fix our collision problem. I'm surprised by that. I mean, it's close. We can see that it's close, but it's not quite there. That should have all of my bases covered currently. Oh, wait a second. I know what is... Actually, do I? No. So, okay, let's plug this in for the time being. Just so that we can keep these separate. Index of nearest, yep. So evaluate an index, and then we get the distance between those two. And we get the greater than node doing its thing. Let me move that outside of the frame just so that I can keep tabs on it easier. Okay. So here's the difference between the two. One is just the position, and one is the offset position. Here, let's try to make it at least a little bit more understandable for my brain and your brains alike. Let's move this over. I don't know why I keep trying to do these things that technically should not be able to be done in Blender with the tools we have. But I guess that's just the kind of programmer side in me. Or, I don't know, it's just the kind of, let's push this as far as it can. Let me move my microphone up a little bit more. So, yes, that collider, so, destination self-collider. So this needs to be the same. So this is destination self-collider with offset. With offset neighbor. Okay. And I spelled that wrong. One of the most consistent things with these streams is me misspelling words by just swapping two of the letters. My typing style is very unique, because I usually have one hand on the mouse and one hand on my keyboard at all times, because that's the kind of Blender workflow. So I very rarely pick up my mouse to type, which leads to hilarious errors such as those. Okay, let's take another look at this. So again, that is a problem. So, oh wait, I need to, let's label all of this to update velocity, I guess. Even though the velocity in this case is just consistent, there is no like real updating when that comes along. It should be good. Okay. Destination self-collider. Let me move this over so that we can see more of the nodes. Again, I apologize for this being so scatterbrained, but I need to test. I need to try it out. Control J. Let me have this as destination. There we go. And plug that into there just so that we can see that in all of its glory. So that does seem to be working as intended. It's just that 1% of colliding particles that is really annoying me severely. And I don't know why those two... Oh wait, those were our demonstration ones. Sorry everyone, still tired. I'm constantly tired. I think that's from doing this all the time. Alright, so let me bevel this just because I want this to look better. The reason I'm doing this effect is because I saw it in the Mario movie. I was like, oh, that looks rather cool. Let me try to do it. Actually, this may help us find... Here, let me see. If I turn on random, I would be able to see which ones are clipping easier. If the instances had their own unique color, which should be the case, but set ID to be random. Does that fix it? No, it does not. Okay. Well, that's unfortunate. I thought that since each of the instances are there, they would have a random color. But yes, apparently not. Oh, attribute. I'm not sure if that would work, but that would be interesting if it could. Actually, let me try that. Is there a way that I can output the attribute? No, there shouldn't be. Realize instances? No, because that would just make it all the geometry node geometry. With it being instances, it should treat it as every object because, little tip here, every object in Blender is an instance. Like this currently is an instance. When you edit it, like, oh, you're not, it looks like you're editing the geometry here, but it's just an illusion. You're editing the data. So if I were to, like, copy this over and, let's say, make it so that the data is the same for both of these, it is revealed. So it looks like you're editing just that, but every instance of the geometry, both of these are instances of the same thing. It doesn't matter which one you edit, you're just editing the base data for it. So these two, as we can see, these ones have different colors because they're, you know, different instances. But since these are technically inside the geometry node's geometry, it doesn't happen, which I do need to check. What if I reference that in here? What happened in that scenario? What happens then? Nope, all still the same. Again, quite unfortunate, but nevertheless. And I accidentally deleted the simulation. Okay, let's label this sim so that I will not delete it. Sim, there we go. Every time you update the name, it updates the index, which will update the random color. So let's turn that off for the time being. Okay. So with that working, how do I make it so that... Yeah, how do I make it so that those few won't collide? Because if we look back in the thing, like, that definitely should not happen under any circumstances. I do not know why it is. Let's see. If the offset position distance to that position is greater than 0.1, it'll keep it going. If it's not, that should not be happening. Yeah, so that collision right there should not be able to occur in any step of the way whatsoever. Actually, wait a second. There may be a fix for that. Let me think about it. So this is the first collider. That one tests if... Try repeating the self-collision. I don't think that would work, because... with it, especially this one right here, that means my math is wrong. Which I'm suspecting it's because this one doesn't take this part into account. Even though that shouldn't really matter. Let's see. I could make two steps, though, that do different things. So one for the destination step, and then another for the other one. So let me try two steps. One, which is just this one, and then another one, which is Here, let me try this to see if it will work. Plug it in. Plug it in. So this will take the velocity, then scale, well, keep it, essentially, only if the distance is greater than that amount. So if I do that... and nope, we still get horrendous bugs and glitches with it. Okay, so let's see why. So step 1, it is very broken. None of these should be moving except for the outside ones. So let me try to... Okay. So in the target direction, yes, that should be working. Should see that. Oh, wait a second. Something was a little bit wrong with it. I need to normalize that. Then that may work. No. Still busted as heck. Okay. Very unfortunate. So let me just... With this version, like, this isn't particle collision stuff. Particle collisions are kind of different, and they're a bit more flexible. While with these ones, they need super precise collisions because it's literally, we're seeing every single step of the way. Destination. What if I labeled that as the velocity and then that just got updated every single time? No, that wouldn't work out well. Let me think. Let me think. If I did want to repeat these steps, I could kind of do what I did before, then see if that would work. Actually, I will try that. So I'm going to try to make a node group where I can take the, basically try to loop this. So let me try. So I will take the current velocity, normalize it, then add it. Okay, let's try putting this into a node group and then try to make it work. Let's scale this by that, so this will just keep it from moving if it's not good enough. So let me put all of this into a node group. Group, make group. There we go. Offsets are very funny when they get reset. So this may make it... Okay, nope. Still sucks. Okay, let's try this. Then that, then that. I am still extremely confused by this. Extremely. Index of nearest. So no, that should be fine. So it gets that position there, and then, yeah, it should compare it to there. I do not see what the problem is. I need to think about this even more than I currently am. Dangerous territory here. So it takes that. Let's see how it differs from the first frame to the second. That stops some of the problems. So I need to think about the rules behind this. So the cube, it gets the index of the nearest with the proposed offset. So its proposed offset is 1 meter over. So this gets the index of the nearest so that I can get the position. So it has this position here. And then it'll compare, it'll get the distance between its target position and this one's current position. That's why I'm doing right over here. So it's getting... Okay, let me break this down even more. So this is position of nearest. So it's comparing the position of the nearest, depending on where the offset is. And then we get the proximity to that. Proximity. So if the proximity is greater than that... Actually, what if this is just a switch? Maybe this is the issue. Because the normalize is just not work. Oh my god, that might have been the case. Even though it's not 100%. Still seems to have a few issues. Okay, so the switch node is the problem. So this is doing nothing. I need to make it so that there will be no data. Or wait a second. So if it's greater than, then it will move. Interesting. So this should be the case. Let's try this out. No, we're still getting as many collisions as ever. So these cannot move at all. I'm assuming that's because the distance is greater. Wait, I need to check the data on this. So let me store some data and check what the issue is. I need to see if this is working at all. Let's label this A. And let's look at the spreadsheet. Again, dangerous, dangerous territory. Spreadsheet, let's take a look at these instances. So where's the data that I stored? Hello, data? Ah, there it is. Let me set this to a Boolean so that we can see the check marks a bit better. Okay. So a few of them are unchecked. Okay. So that means some of it should be working. Some of them should be able to move if I disable all of that. But turns out, again, not great, and I am very confused as to why. Okay, so the first step is just broken, just straight up broken. Even with the broken version of it, these should be able to move. These ones should not. So let me try to fix this broken code of mine. Okay. Let's try this one more time. Okay. So here we can see. Here, let me just plug this in. Let's return this back to basics before we complicate it again. So step one, these front panels, these ones here should be able to move. All of these ones should not be able to. So I need to make sure, I need to figure out why that is not occurring. And then we could do like the sub-steps later. Okay, we don't need, no, I'll keep that in there just in case. So let's think about this. We have the offset to where it wants to go, which is 1 meter. Oh, shoot. I need to check some more data. I think there may be an issue with it. Label this B. B. Nope, that data is fine. Okay. That needs to be 1 meter. So that is fine. Taking the current position, moving over 1 meter, which this gap is 1 meter, not 2. So, okay. I should try this with 2 of them. So let me go and reduce the amount of... Here, let's have one version that is just 2 cubes, so that in the spreadsheet I can actually see what's going on reliably. Okay, so let's hide that. Let's move this over to there. Let's move this back. I don't know what those two are doing again. Okay, so let's see these two. These two want to move that way. Okay, wait, why did that one work? Wait, why did that one work? That's how it was supposed to go. The first one moves and then the other one can follow. Okay, okay, okay. Let's add in another. Okay. Okay, so 1 being behind causes an error. Hmm. Yeah, no, that should not happen at all. Two are the same distance. Well, that is the thing. This should look over to the side. So, right now, the index of nearest, I have it offset by 1, so imagine the center point is right there. This is looking all the way over to here, so the nearest in the index should be that cube, with no exceptions whatsoever. The thing is, it's getting that position, which is accurate. Then it's getting the distance from that, so that if the distance is greater than, it should be able to keep it moving. Or I could just make all these loops, and then if we had 4 each loops, this would be a breeze. But something's just very wrong about this. Here, how about instead of that, let's make it so that it is guaranteed to be 1 meter over. Let's give that a test. So, x1. Okay, so that's broken. Let me use a geometry proximity. Okay. So, I'm not sure if this will do something similar, but I want to try with actual geometry just to be sure. And let me also just delete this named attribute so that I, Okay, why does that work? That's how it should be working, but why? Because that... Yeah, no, this should be doing the same thing as the geometry proximity. Wait a second. Where's the big one? Why does that work? With the old version. And then, it freaks out when that happens, but I think I know why that occurs. It's, yeah, the destination location. Yeah, okay. So I know why that's happening. So remind me, why the heck is the geometry the old version? Why is that working until, that happens? I am very, very confused by that. Okay, well, index of nearest, don't need it. I might actually need it, but we'll just ignore it for now. So let me try what we know works now and put it into our multiple step thing just to see. I'm very curious about it. So we need... So this one does not ignore itself, but then again, since I do have the offset doing its thing, it should... Don't tell me. Okay, no, so it's still broken. So here's one of the issues that I was talking about. We can see with this one, since it checks up there, since it checks up and down, currently... Actually, wait a second, no, that shouldn't be happening at all. No, since it's checking its future position... Yeah, no, that should not occur. Or wait a second. Wait a minute. I know what to do. Okay, so let's start this almost from scratch. Not quite, but almost. So we don't need any of this. We just need you. You? The position offset. Since this is one... Okay, we're going to do a manual check for every single cube in here. So we'll offset it by 1 meter on X, Y, and Z, and also in the negatives. Each time this happens... Okay. X, Y, Z, and then negative, negative, negative. Okay, so it's partly broken. But let's see what happens. So we'll feed in that velocity. We don't need that. We don't need that. So we just need this and the colliders. The only part where this should break is if there is a diagonal. Okay, let's give it a go. Okay. So, if I'm correct, some of these should be able to move. So there's the distance. Check. It's just offset by 1 meter. It's the distance. Then it says if the distance is greater than, then it can move. So it checks the left, right, up, down, side to side. Oh, wait, but this means... Okay, if there's one isolated, it will be able to move, but as soon as there's one in the proper proximity. Yeah, that one can move. These ones cannot because there's one next to it. So this gives us accurate collisions if there's one up, down, side to side. So if there's one here, if they're attached, it can't move. I need to make it so that if there's a free space, it'll be able to move there. Right. Yeah, how do I make that happen? How do I make that happen? So, see all the available spots. And then pick one to go to. Let's take a look. I mean... Because currently this is just saying, okay, if even one of these is occupied, then don't move it at all. I need to fix that. How do I make it so that it will always be able to move in that location? So if it can't move in that one... That's not quite what I envisioned. Oh, and also I need to have the interpolation part be correct in here, but that part is unnecessary. So that's basically the inverse of what I want. So this tries to move them all into the same location, which is, yeah, again. So this will try to move, but going into the available spots. Oh wait, but this will have the same problem if they both try to move in the same location. Okay. Alright. Let me think about this a bit more. No. So that one works. Okay. Further and further, I'm being driven to insanity, trying to do something that Blender should not be able to do just yet. Or, it shouldn't be able to do extremely accurately. Like, that's the bane. Like, this is technically working. But the problem is, we can't decide if two of them, here's the perfect example, if two of them see an empty square, they can move there. Both of them, they can. But the thing is, I need to make it so that they both look in there and then say, oh wait, I cannot, I should not be able to move there. It is extremely unfortunate, but I have to figure it out. I have to figure it out. That may be a case where the index of nearest node may be good. Okay, so let me try this. One sample of this should give the same results. Yeah, okay, I was right about that. So that gives us the basic collisions, where all the collisions should be fine unless two of them have the same location they want to go to. That's fine. So I'm going to copy this. Well, step 1, we don't need that vector group input at all. So, wait, let me eliminate both of those. Okay. So this one is working just fine. It's as expected. Isn't it midnight for you? No, it is currently noon for me. So you're about 12 hours off. So there's that. So now, through a lot of trial and error, this is a lot of trial and error, more than I'm used to. Because we're almost at an hour and we are not done. At all. So let me also label this. So this is only x/y switcher. There we go. So this will only make it so that... Do I need the ceiling on there? Yeah, let's just keep that as a kind of safety check. Okay, so this might be where the index of nearest comes in. So instead of the geometry proximity node, let me put this here. This is only if. Move only if space. Only if space available. There we go. So now this one, let's have this be the index of nearest so that I can see its own geometry. Like its neighbors without having to do that weird stuff. Yeah. So that should work, and then we evaluate at the index. We see what it is at the index. So we do that, we look at the position, then we need to get the proximity, the distance. So let's delete that, and we just need the distance between that position and the current one. So if we do that, no, we are still getting the errors, and that basically did nothing. Okay. So I need to think about this. If we plug this, let's just try all the combinations and see what works. Because that's the point I'm at the moment. The offset, no, it should compare the offset to that and that. I keep thinking, oh wait, maybe this one works, but then no, it shows that it really, really does not. Because that is the issue. Once a lower index cube reserves it, it blocks it from all the later indexes. That's what I'm trying to do. But the thing is, that's where for each loops would come into play. Actually, I should look up the definition of for each loops just to be sure. Let's see, let me look this up real quick. For each loops. Vertices. Okay, yep, that does make sense. Just double checking that I'm not talking out of my you-know-what. So yes, current problem is right here within the first couple frames. These two see an empty cell, they both want to go there, but then they're like, wait, we can both go there, and then they're like, oh no, wait, why are we both here? Yeah, I wish we could do that, but currently that's the last big thing we need in, geometry nodes. Which they have made plans to do that, like they made a full mock-up for a plexus effect, something that also needs that effect. But that was months ago, and as far as I know, nothing came up. But it was with a similar node setup with the zones to the simulation nodes. So I'm hoping, this might just be copium, that now that the simulation nodes are merged, they might make the loops because they're similar. Just one doesn't need caching. Okay. Yes, so this should say, okay, so let me think about this. This has the offset. So this one's offset is right here. That's where it's looking. It's looking here to see where the nearest one is. And this one is current... Oh, wait a second, that explains it. Hallelujah. There we go. Nope. Wait. Oh, phew, I thought there was a bug, but turns out no, it was the other object. Yay, okay. Let's take a look. Does it work? It better work. It looks like it works. Extremely well. Ah, finally, okay. So that was the setup. Okay. So through much trial and error, we got it. So all these need to be the same input. And it turns out this isn't that bad of a setup. Not too many nodes are needed. So now I wonder, what happens if I take out the original? Okay, so if we take out the original, some bad things still happen. So we need that as well. And maybe I could use the index of nearest for here, but I think that's what works with the fewest amount of nodes. I'm not going to question it. For now. Okay. This is position with offset with wanted offset. So let me put that back here. With wanted offset, or maybe requested, I don't know. And then this is the proximity check. Or no. No, let's get this out of the frame. This needs to be in the frame. Just to get these ones in sync. So this is... if space, then keep moving. If space, then keep moving. Then that's just proximity. Proximity. There we go. Okay, so let's put this in the other one. So let's do this. If space, then keep moving. And this is proximity. There we go. So I just needed to... I could have... Okay, so I just had one of the setups wrong, which caused all of that pain and suffering. So now this is correct with no collisions, for all the ones in the same thing. Finally! Okay, now I can rest. 1 hour, and I finally figured it out. Which maybe I should save it at this point, but then again, that's partly why I stream, because everything gets saved. So, this is... Wait, what is this? Okay, this version is... That one is with the offset. Is it possible to create the Doctor Who intro in Blender? I would think so. I'm not too familiar with that, though. Okay, so both of those... Yeah, I need to... Okay. So both of these have the offset. Wait a minute. I'm going to try something. So, with this one... Let me just try this. That one does collide. Force position. So this one Oh, okay. Compare that to that. Interesting. For some reason, my brain is saying that... Yeah, no. This should be working, because this just offsets where it is looking. Well, that should be fine. Very interesting. I need to... More research is required. I think it's just... Now I'm just like, oh, let's try every single input to see which leads to the correct output. No. So position in there, this gets the position of the other one, same as that. Then we get the distance to the current one. That should be this. So these two should be able, yeah, these should be the same thing. Well, if this one works and the other one doesn't, that's okay. I'm not going to fuss about it. So this is destination collision check. So this is just destination collision check, and this is just collision check. So both of those combined does work, but I find it very, very odd that I need to check both of them. And actually, I need to check if... No, they can... Yeah. No, this seems to work perfectly. I'm very confused. Could this one work with just the geometry proximity node? Proximity. Let's check this. So if that, and then we add the velocity to the outputs here. Then we put the distance in there. We get the... That do the same? No. Okay. Well, okay. We got it working. Let me... I don't want to test fate anymore. Okay. So now we can get back to the fun part that I should have been at 30 minutes ago. 40 minutes ago. Okay. So we can see here how often these fire the collision checks when it was baking. Okay, let's do that. So we can see here this fires only every 10 seconds when it needs to do another collision check, as this required. Okay, so this is... Yeah, just... time loop. Let me just label that. And that's just movement. There we have it. So these are the collision checks. Collision checks. Whoops. Now the thing is, I could break them out of those nodes, but I'm gonna keep them in there. What happens if I reverse the order, though? Let's take a look. Wow. Okay. Even if I reverse the order, it works. I am a little surprised by that, but... No, actually, that does make sense. That makes sense. Okay, now, what was I going to do? Oh, right, I need to have the destination, and I want to make... Let's make the destination... Let's try this as a curved circle. So I'm going to sample curve. I'm just going to... Let's see if I can get these to go into a circle formation with their programming. Let's have this be random value. Just plug that in. Yeah, let's snap this to 1. Let's see how that goes. Well, that is alarmingly slow. Actually, wait, yeah, why is that, Oh, I know why. This seems very complicated, not gonna lie. Well, you are correct. 100%, this is complicated. So this isn't foolproof, because that should not be happening. Somehow, all these got stuck, even, like, okay, let's delete those ones, because those are just confusing me. Oh wait, that means I would have to try to do pathfind. Oh god, no, I'm not gonna try that. Okay, so we can see that these ones are trying to... Yeah, they're trying to do that. So yeah, this front one, for some reason, can't decide on moving, so it halts the rest of them in the back. With this version, it staggers the... when it moves on the X or Y every single time. Yeah, we can see that happening. So the question is, 1, why is it taking so long? And 2, it should be faster than that. Did I just say the same thing twice? I think I did. So that's the question. Why did that stop? So these should be able to just keep going. But for some reason this one stops. Why? Okay, let's make it so that I can update that live. Oh wait, is that because of the snap? Let's change this to, no, let's change this to just the position. That there cannot be any more annoyances. Let's get rid of all of that. I just want the positions. There we go. So that's the target. Right there. Nothing else to complain about. So it's trying to get there. They're doing their best. But what I'm wondering is why their best isn't enough. If you see some of them kind of clipping, that's because they're trying to do diagonal moves, which really shouldn't be happening. How do I make it so that the rotation vector is snapped to one of them? And oddly enough, in this case, the diagonals are making it so that they can move more. Or actually, let me turn off the timer so that this happens once every single frame. Here, let me do that. There we go. Now we can see this happening better. And they cannot move that way for some reason. Wait, does the ceiling node do that? Let's change this to... Is there a round node? Wait a second. Let's set this to snap, just to... Okay, so that happens. So, snap cannot go backwards. I kind of knew that. But what I'm wondering is, these ones should be able to. right? Okay, I don't even need those because I have to normalize, but I'm still very annoyed by that. Okay. Uh-oh. Oh, wait, no, that was the reason why I was... Okay. Yeah, the reason I had the snap was so that it would only go, like, forward, up, right, down, and all that. So how do I make it so that this only goes in one direction? One direction. Yeah, I need to look at the shader editor to see what these nodes do. Sorry, folks, one moment. Let's take a look. So let's look at the object, the texture coordinate node. When I need to figure out what vector math node does, I just look at the shader editor because I can see the data. So let's take a look at this. So let's snap this. So this, as we can see, turns it into just 1, 2, 3, 4, 5, 6, and all that. But I need to. Let's see what absolute does. So it does affect it in both directions. That's good. Floor. That works. Ceiling. That also works. Okay, wait, let's try adding this. I need to. Wait, all those work in the positive and negatives. I thought one of them didn't. Huh. And there's that. I knew what that did. But it does work very well. And a little side tangent. Here, let me try this. Separate. Just got this idea. So let's use a compare node. 0.5 and 0.5, 0.5 and 0.5. Let's multiply the two together. There we go. So here, that's how you get just squares that you can space out like that. Could be cool for something. Actually, yeah, let's set that to 0 so that... There we go. Just a little side thing. Alright, so yeah, I need to make it so that this can only fire on one axis at a time. I could do it the very manual way, like I had there. Which would work, but it feels very, like, cheap and cheaty. Wait, what? Why did... Wait, wait. Should still be properly normalized. Okay, there we... That is really weird. Yeah, no, that... Yeah, that's normalized when it goes in. So we can see this freaking out, but okay. That should only... Yeah, I need to make it so that the distance between these is less than a meter. Then it stops moving, so let's do that. Switch. Let's use a greater than, so that the distance is greater than 1. It will still move. And I need to actually connect it. Or else these things will never settle whatsoever. Oh wait, that's because they can't reach their actual final destination. Huh. Fun. Because they're all trying to get into there, so they will keep freaking out till the end of eternity, trying to settle. Maybe I should make this so that they'll switch every second. Why are those freaking out so much? Yikes. Yeah, no, so that's not the problem. The problem is these trying to figure out what's going on. Okay. Let me re-implement the interpolation process. Except, let's have this be every 4 frames, I think. Yeah, I need to just fix that so that it cannot happen. That just reeks of instability. Okay, let me switch it back to updating every single frame. Just so that I can easily test it. Yeah, why would it go back? Oh, wait, I know. Okay, yeah, I know why. So if I were to snap this, it should fix the issues. Snap the... Yep, there we go. Okay. So every single second, it'll do that. Okay, so now if I set that to frame, there we go. So it tries to go to where that circle is. In the endpoint, I wanted this to be like text. So let me try that. String to curves. Realize instances so that they're actual things. So this will be 1, 2, 3. Let's just do that and let's make the scale 10 times as big. And let's bring that plane object into here, set it to all curves. There we go. Let's see what happens. Well, it's trying its best. And they cannot move on the z-axis, which is annoying. How do I make it so that... Okay, wait, I just need to set this to integer so that it can move one of 3 directions, and then it's equal to... Or no, 0, 1, 2, because that... No, 1, 2, or 3. 1, 2, 3. So it's 1, I'll do that, 2, and then 3. There we go. Well, it tried its best. For a second, I thought there was snow flying out my window, but turns out it was flower petals. It's springtime, after all. There we go. So let's see. It's trying! It's really trying. Okay. Yeah. Unfortunately, these don't have any, like, real pathfinding. Again, another thing that we need for each loops for. But it is very funny to see it try. Okay. So what if I had the index? We divided this so that there's an even distribution. This might work. Domain size by the point count. Let's see if that gives a more even result so that we don't have those huge pile-ups. I mean, it kind of worked. Here, let's just send this into overdrive. So let's make this text 3 times as big and make more particles. 2, 2, so that it can... There we go. It's trying its best, and it's actually partly succeeding. Even though, it, again, not the best. So let me try that domain size thing again. Because this places a virtual destination point on every single, you know, on a point along the curve. Since this is random, it's a random point along there. I want to make it so that they're all evenly spaced. So divide the index value by the... Oh, wait, I need this to be the opposite. There we go. So now we're getting a little more of that almost... There we go. Yeah, you can see that. Yeah, it's trying. It is trying. Okay, let's bring it down and... Dang, that is... I need to do some sort of pathfinding things. Can you increase the number of blocks to fully outline the numbers? Well, that is the problem. The thing is, they'll all stack up like this, because they can't collide, but they also have no idea how to get around each other in that scenario. So let's just make more cubes. We almost have 50 people here, wow. So it seems like during the day, people can stop by the streams more often. Interesting. Okay, let's take a look at this. So there's the problem. Since they can't make it, that happens. So, this is where I would have the checks to see if any place is available. And if you can't move anywhere, and you're not close to your destination, just move in a random direction. I guess I did just make Minecraft sand in this case. Okay, let me raise the text back up. It is trying its best. Oh, and we can even see... Oh, almost pathways starting to form. Wow. Actually, how do I make it so that I can see... To make the, like, destinations more accurate, I do need to make it so that I'll just choose one of the most... Yeah, how do I do that? Face forward, could that be it? Yeah, how do I make it so that I'll pick the vector it's closest towards and only that, instead of this, like, noise, like, oh, pick that, that, or that, because this isn't fully accurate. I think there is a way with, like, I don't know, align Euler to vector, like we do this, plug the normalized vector into there, then we use the vector rotate, rotate vector, but no, not that. We need to set that into the Euler, and then we have a vector in here. Oop. Vector, which is just 1, but we need to snap that rotation to be pi divided by 2. Ah, well, okay, and that's freaking out, of course. Wait, why would it be freaking out like that? I need to round it, not whatever that is. No, there's no round in there, which is unfortunate. More testing required. We are at 1 hour and 28 minutes. Which is... yeah. Fun. Oh, whoa, whoa. Wait, what? Why did that work? Oh, I know why it worked. I know why it worked. Because it completely ignores all of its neighbors. So if we do that... yeah, okay, that's... I divide by 2. That's just so that the radians are kind of correct. What? Wait, pi? No, it has to be pi, right? Aha, that is something. Oh, where are you guys going? Wait, so... oh, no, it has to be pi divided by 2 because that's 90 degrees. Yeah, I don't know why those are freaking out so badly. Because they're trying to reach the center, as we can see. But they just can't. Is that where I need the kind of, yeah, the length thing? Let's try it. So switch. If the length is greater than 1 meter, then keep moving. Okay, there we go. So that stops that weird stuff from happening. But since there are so many blockades here, or wait, I can do this in a simpler way by, okay, by multiplying this output, and let's just normalize it just to be safe. Normalizing means that'll go to 1 or -1, which is what I want. So I just need to say, hey, if this vector, if one's greater than the other, or if the other is greater than the other. Yeah, okay, let's separate x, y, z. Float, this needs to be a greater than. So if x is greater... Wait a second. X is less than b. No. If x is greater than y. I think that's how it does it. Wait, let me... And if not... Not. It'll go on y. Let's see if that's right. I feel like that is not correct. Less than? There we go. Okay, that seems to work. No, it still does not work. Why is it only working on one axis? Oh wait, I need to absolute this. Absolute the input so that the negative values are ignored. Then I change that to greater than again. There we go. See, it's trying its best again. Trying again. Yeah, I need to make it so that it will go around its neighbors, but I do not know how to do that. And also I need to input the, if, you know, if z is greater than both of those, then I'll do that. So if z... Actually, wait a second, I need to have this as switches. So switch, booleans. Wait a minute, I'm tripping up again. Okay, let's have this just be a 2D simulation for the moment. I'll figure out how to, you know, mess with the other thing later. Okay. So there's that. Actually, what if I plugged this into here? Would that lead to the same simulation? It would. Okay, so both of those could be the same. Okay, so next thing, and probably the last for this. How do I make it so that these cubes decide to avoid each other if there is a collision? I could label a... Yeah, okay. I can say, oh, if the velocity is 0, then have, like, move where it wants to look. Like, rotate the velocity a random value. And then the next frame I'll just do the calculation again. And if it's still broken, it'll just keep doing it until it can settle. Yes. Okay, let's do that. So yes, I have the previous velocity. So if the velocity length is, if it's less than, if it's equal to 0, then we'll have the velocity, the target, not be the actual target, but a random value. Okay. So, let's see, let's do the... We don't need to normalize before then, we can just do that. Switch. So, if that is equal to that, then we want this to be a random value. It'll just be, every single frame will be something different, which means that there will be more visual noise. This is not an intelligent way of doing this. It's it's kind of like noise dithering, I guess. Oh, wait, oh my goodness, okay. So, we can see that it works. Things go where they need to. But, they don't stop when they're close enough to the output. So, I need to put another little caveat in here that says if the length here is... Let's see. Yeah, if the length there is greater than... Let's do 2 meters, just to be safe. Both of these, that and that, have to be true for that to work. Let's try it. I think I had that inverted. Or no, it is kind of working. They're trying their best to get to their destination, but oh wait, since I don't have the Z part working yet, they cannot get there. So they will keep trying. So let's see, only x/y. So yeah, I need to do that thing where I'll snap to whatever orientation. If anyone knows how to do that, I'm all ears, because I guess the only way to actually do that correctly is to do like the align Euler to vector version, which I do not want to do again, because that was annoying to work with. But the end result of this, I want to make these like little robots that go and construct stuff for me. But I do not want the robots to collide. So yeah, I need that Z-axis thing working. So this is... let's try to put some of this in a frame. If stopped... this is just... Here, let's move this over, put into a frame. This is... destination, position... There we go. Destination, position. That makes sense. And that's just for the even distribution along the curve. Blenders for complex thinkers. I guess, but this is geometry nodes. Literally stuff that... I'm using stuff that isn't out yet. So I'm literally trying to do, essentially, actor programming, in quotes, in a way. I'm trying to make intelligent Minecraft sand, if that makes it better. Okay. So this will be the move randomly. I need to stop doing that. Okay, so there's that. Let me put that into reroute. Let me put this as if close to target. Close to target, both of those need to be true for the move randomly to occur. That's just so that it's like jostling, I don't know, just jostling it so it can settle. Okay, so that's that. The collision detection is doing its job. And now I need to just make a better XYZ switcher. Let's use the align Euler, yeah, to vector method. X, let's use a rotate Euler, put that into the, vector rotate. No, and we need that on the Euler one. There we go. We want the vector to be on the x-axis because that's what the align Euler to vector node has. So that will give us, oh wait, and we need to snap this. Snap. Snap, crackle, and pop. I'm not sure if I need to, like, add 0.7 then subtract to get, like, the midpoint. So that will be more of a round. I forget how the snap works. But we can see that is working. I'm actually surprised it's not freaking out. So there we go. This is just snap to x, y, x or y. No, x, comma, y, comma, or... I cannot spell. I think I've spent all my brain cells today. Snap to x, y, or z. So I can get rid of that. So that is actually a fairly elegant method of doing that. I was just worried that a ton of noise would occur. So we can see that these try to do their thing. But some of them still freak out. Oh, look at that one. The poor one's trying everything it knows to try to get into where it's supposed to be. Then those ones are freaking out, I think, because of that problem. So I need to do if the distance is less than 1 meter. Float. The distance to the target is less than 1 meter, then it'll switch to this being nothing. So that should calm. Oh wow. Whoa. So some of those will never rest because they cannot find, they're trying everything until they can find a safe place to rest. But then if I have it so that that happens, yeah. So that's like this one right here, that's like the close enough to target. But then this one is like the actually, is it close to target? Just so that it stops freaking out. If within 1 meter. There we go. So now we can see that that does work. I do find it interesting how these ones bias going up before down, or side to side before going down. Okay. So this will be stop if close enough. There we go. So yes, through 1 hour and 44 minutes of testing and, well, my brain taking a beating, we finally got a workable version. There we go. It should not have been this difficult. Again, if we had the for each loops, this would have been a lot easier. But even without, this is... we got it working. It's alright. And there we have it. It's 12:26, so I should end the stream now that we have a working version. But let's also show off the interpolation again. This is, what, every 4 things? There we go. So it's essentially what it's doing, except severely slowed down. Which is, yeah, I'm not sure if anyone would want that with how slow this moves, but it is kind of satisfying, seeing all the parts slot into place. And the ones are just like, hey, let me in. And then they're like, oh, I found a place. Oh, that one will never find a place close enough. I should make the seed value a... Wait, how many random values do I have in this? Not many. Okay. Let me switch this to 0.5 and that to 2. So that, there we go. It is interpolated, but just every half. Even though it's still painfully slow. But that one just zooms over. So, accurate self-collisions. Very nice. Okay. Come on, you can do it. There we go. Okay, so now they're all settled. Very nice. So again, I'm just going to make it so that this moves just 1 meter every single frame. I could interpolate it any other way. So I could try to make it so that they all have a random destination position inside of a volume. Oh wait, that might... How would that work? How would I make a random location inside of a volume? I mean, I could... Okay, let me try this. Let's go to 2 hours, and then I need to go and get myself some lunch. Who knew that, depriving yourself of food while doing hardcore math would be, bad for your health. Let's label this destination. So I'll store the destination value before the simulation starts, just so that that doesn't have to constantly update. Should be faster, even though this is a rather fast simulation anyway. Let's just put that there. Let's move that over. Okay. So the actual collision isn't bad. Like, in there it's just that and that. So that is something. Then I could, if I wanted to get rid of, yeah, okay. Let me just move the interpolator out of the way. Let's have this as the simplest version possible. So just that as the offset. I'll keep it not normalized so that I can tell if I broke something along the path. There we go, there's that. There's this, let's bring this all the way back. So, you know, yeah, that's not the most complex node setup I ever made. But it was just a pain because figuring out that math, God. Took an hour just for the collisions. One day we might be able to make procedural food. That's already very, very possible. Or if you mean like grow the food, like with cells, that's a long ways away. A very long ways away. Okay, so I have an idea. If we have just random points, random value. Okay, let's try this in a different way. So let's have the monkey, just like this. New. So let's do mesh to volume, then volume to point, or no, distribute points in volume. So I'll just have a bunch of random points in this volume. There we go. Just tons. Random or... Oh, we can do a grid. Nice. Or do we want random? Let's do random just so that... Yeah, let's do that. So we want a lot of them. And the voxel amount... Yeah, well, let's just bump that up to 200. I'm surprised we're not getting any in the ears. Grid. Yeah, random. Okay. So we do that, and then we do a sample index node on the monkey mesh. So that vector, we just want the position. There we go. We need this to be the index. Okay, so this should make it. That needs to be set to relative. Here we go. They will try to make the form of the monkey as best they can, which is not great. Because the middle ones do not go first. Maybe this wasn't the best GeoNodes project to work on. 2 hours in. Yeah, that's not something you want to be saying. Like, it'll try to make a form, it just won't be great. Yeah, let's just leave it with the curve version for now. This is a good version. Actually, I want to try this on just a line, just to see what would happen. So, geometry node editor, let's go into here, let's make this a curve line. There we go, let's just have this a line that's like 50 meters on the x-axis. Just to see. So it can assemble like semi-structures. Kind of. Very interesting. So if I had like here, let me try this. So Z, something like that, and then let's rotate the middle, scale it out. So something like that. Let's see if it'll work. We just need to convert the mesh to a curve. There we go, and maybe scale up the mesh by a considerable amount, because let's not forget, this operation runs in the meters, not the centimeters. There we go. I guess that does work. So if you did want it to like assemble some semblance of a structure, you could do that. So let's try this out, just making this curved and then deleting the inside edges. If I can select them without selecting the middle part. Edges, there we go. Nope, do. So I guess this is a good idea. Well, if the curve was animated, then that just means, yeah, that could be done. That just means that the voxels will try to reorient every single time. Here we go. So I guess all in all, it's not bad. Let's go and make this grid of cubes a bit better. Start grid. Ah, there we go. Let's go and boot-to-do. Let's try to make this like 1 meter by 1 meter by 1 meter. Or maybe 0.5 meters on the top. Okay, 1 meter by 1 meter by 1 meter. Let's try that out. Okay. So I guess, yeah, it does kind of look like the Mario movie version. Like, the Mario movie was just, you have cube, and the cube just go do-do-do-do-do-do-do-do. In this kind of algorithmic pattern. Except theirs was, you know, a little bit more animated. Well, mine is extremely linear. But that is by design. Do-do-do-do-do. And also, I could scale down the simulation to like 0.1. So that I could keep things relatively fine. Like, oh, look at that. They are trying. But no, I think it's better if we... Oh, but yeah, here we can see what would happen if it were, like, completely normal. No, let's bring it back to real scale. It moves 1 meter every single frame. There we go. I do kind of like the interpolation, which actually, how would the simulation work if I had it move 0.1 meter every single frame? Yeah, no, clipping occurs. Yep, that's to be expected. Because it looks the next voxel over. So I guess what's left to do is to be like, oh, what other kinds of... I guess skinning it. Seeing what kinds of looks look the best on it. Which skin would look best on this? Kind of chrome, just... Oh, looks like viewport denoising is hating that. That is way too noisy. So maybe they should be, I don't know, white particles? Maybe red particles. Alright, this is in a good place. I'm happy with the result. You know, it probably shouldn't have done this now because, you know, it is such a rather big undertaking for me, but yeah, we got there in the end. You know where this is going, orange? I kind of like red in this case. I know that's unheard of for me, but I don't know. Orange doesn't really fit the aesthetic. Actually, wait a second. Let's go into this shader. Oh no, we're gonna hit 2 hours. Okay, I'm going to stop the stream before it hits 2 hours. I'll edit the colors later. I refuse to do a more than 2 hour stream. So, thank you all for watching, and I will see you maybe later today. We'll see what I am going to do. But yes, almost 50 viewers. Okay, bye-bye. Thank you. Bye-bye.